On May 13, 2019, the black hole at the center of our galaxy became 75 times brighter than it had ever been recorded before. Nobody knows why. Tuan Do, an astronomer at UCLA, was operating the Keck telescope in Hawaii that night. He had spent 20 years studying that exact point in the sky. When he saw the first image, he thought the equipment had an error. When he saw the second, he thought he was looking at the wrong star. When he accepted what was happening, he knew two things. Sagittarius. A star had just done something impossible. And it was not the first sign. This is Deep Field. Subscribe. Every week we cover the mysteries science cannot close. To understand why that night in Hawaii broke 25 years of scientific consensus, you have to go back to the beginning. For a quarter of a century, astrophysics sold you a very specific story about the black hole at the center of your galaxy. That it was sleeping, that it was starving, that it was the quietest of its category in the known universe. Reinhard Genzel and Andrea Ghez won the Nobel Prize in 2020 for confirming exactly that image. 4 million solar masses were concentrated in one point, feeding on crumbs. The object's luminosity was billions of times lower than that of active black holes in other galaxies. The occasional flares were explained as asteroid fragments falling in. Nothing to worry about. A sleeping giant at the heart of the Milky Way. But the cracks in that model started appearing long before Tuan Do's night. They started in 2012. That year, astronomers from the Max Planck Institute in Germany detected something on a direct trajectory toward the black hole. They called it G2. It was a cloud of gas and dust the size of 3 Earths spiraling inward. The models were unanimous. When G2 crossed its closest approach in 2014, it would be torn apart by gravity. The gas would fall into the gravitational well, heat up to millions of degrees, and Sagittarius, a star, would wake up with an X-ray spectacle visible from Earth. The best observatories on the planet pointed their instruments at the center of the galaxy. They waited. The date arrived. Nothing happened. G2 crossed the critical zone, survived, compacted again, and continued its orbit. The black hole did not react. Daryl Haggard, the researcher leading the Chandra monitoring, recorded it without disguising it. The gas cloud did not produce the fireworks we expected. What did not make the headlines was what happened next. While the black hole ignored G2, Chandra detected a flare 400 times brighter than the base state, with no visible object to explain it. A year later, another flare, 200 times brighter, appeared in the same region. Astrometric analysis confirmed that those explosions occurred 100 times closer to the event horizon than G2 ever was. The black hole did not respond to the stimulus everyone predicted. It responded to something nobody saw, something that is still there. And from that moment on, the discoveries started arriving in a cascade. 5 years later came the night of 2019 that opened this video. The luminosity dropped by 75 times in 2 minutes. Statistics declared it had a 0.01% chance of belonging to the normal historical range. Something had changed permanently at the center of the galaxy. But the worst news came after. In March 2024, the Event Horizon Telescope published the first image of Sagittarius, a star in polarized light. What it showed were magnetic fields structured in a spiral around the event horizon, an architecture identical to the black hole at the center of galaxy M87, which uses that same configuration to fire a plasma jet 5,000 light-years long, piercing its entire galaxy. And in February 2025, the team of Farhad Youssefzadeh at Northwestern published the most detailed observations ever collected. 48 continuous hours with the James Webb Telescope. What they found dismantles the sleeping giant model completely. The center of your galaxy has no resting state. The data showed a constant bubbling in the darkness, 5 or 6 massive eruptions every day. James Webb detected an exact delay of up to 40 seconds between 2 emission bands, which implies the innermost region of the disk is dominated by continuous magnetic reconnection. Invisible field lines breaking and rejoining, like cosmic rubber bands snapping with the force of millions of suns over and over, without pause. That same year, Ruth Daly at Penn State measured the S-spin of the black hole. The result was 0.90 on a scale where 1 is the absolute physical limit. The singularity at the center of your galaxy rotates at 90% of the maximum speed allowed by physics. That matters for a very specific reason. A black hole with high spin and structured magnetic fields has everything it needs to activate the mechanism that converts rotational energy into lethal jets of radiation. 15% of the total mass of Sagittarius A star, equivalent to 600,000 suns of pure energy, is thermodynamically available to be released. Anan Liu from McGill University described it this way: although it is quiet now, in the future it will give the surrounding matter an incredibly powerful kick. It could be in 1,000 years. It could be in 1,000,000. It could be during our lifetimes. The only reason it is not happening right now is that there is not enough gas near the event horizon. It is not a safety mechanism. It is not a permanent equilibrium. It is a loaded cannon waiting for fuel. What XRISM, James Webb, IXPE, and the Event Horizon Telescope are monitoring right now is not whether Sagittarius A star can ignite. That is already answered. What they are looking for is what will trigger it: the light. Tuan Do saw that night on Mauna Kea left the center of the galaxy 26,000 years ago, when the first modern humans were still hunting mammoths. What the black hole is doing in this exact moment, while you watch this, nobody will know for another 26,000 years. We can only sit in front of the telescope, like Tuan Do that night, and hope the next flash is not the glow of a weapon firing.